The broadcast is now starting. All attendees are in listen-only mode.
Good morning. My name is Scott Peterson, and I'm the Marketing Coordinator here at TriStar. I'd like to welcome all of you to today's webinar on Creo 3. Today, we have Sean Schreckengast, an Application Engineer with TriStar, to talk about some of the new features and functionality within Creo 3.0. Before I hand it over to Sean, let me go through a few things logistically. This webinar will be recorded and will be posted at the TriStar Resource Center. You can find this by going to www.tristar.com and clicking Resource Center at the top right of the page. The recording should be available by the end of today. Should you have any questions during the presentation, please enter them into the Questions tab in your GoToMeeting interface. We will answer as many of these questions as we can after the presentation is over. And with that, I'd like to hand things over to Sean.
Thank you, Scott. Good morning, everybody. Welcome to TriStar's exclusive preview for Creo Parametric 3. My name is Sean Schreckengast. I'm a TriStar Application Engineer. A little bit about myself. I've been with TriStar for almost 3 years now. Prior to that, I was with PTC for 16 years, working in both consulting and education. I've been in the industry since the early 80s, with my first CAD system being Applicon Bravo 900. I know that many of you may not be familiar with that, but if you did see the original movie Tron, Applicon Bravo 9000 is the software they used to do the graphics in that movie. Today's presentation, we're going to cover several new functionalities and enhancements to Creo Parametric version 3.0. We have some general help things to discuss, some part modeling enhancements, sheet metal enhancements, some great enhancements to the flexible modeling environment as well as the surfacing environments, some graphics handling issues, some enhancements to the rendering environment, and some enhancements to the assembly environment. So to begin with the just general help options, there's some new adoption aids for getting started with the tool, as well as some new help tools available. There's some expansion of the library suppliers for the commercial off-the-shelf components. There's a new extension for intelligent fasteners, and some application compliance with Windows 7 for some automatic window activation, right mouse button commands, and version extensions. So first of all, the getting started experience has been greatly enhanced. There's a revamped help with some Google indexed and searchable items on the web. There are also startup tutorials shipped with the product. There is also additional tutorials available through the Learning Exchange, as well as some new videos available on the Learning Exchange. As far as the expansion of the library suppliers, there's the Catalog Data Solutions. They provide a Google-type approach for searching for library objects. They are headed in the United States. There's also the Cadence library support. They're headed out of Europe, but this is a single user interface, single login type library access. They have offices also in the USA, Japan, and China. They're also localized into the various languages. With the new Intelligent Fastener extension, this greatly enhances the ability to assemble fasteners in your assembly, as well as to create the necessary features such as holes and counterbores and countersinks with the required fasteners. With this extension, you can very quickly create fastener assemblies, reducing the amount of work from about 35 mouse clicks, 96 seconds, down to about 11 mouse clicks and 19 seconds. So with a very little bit of training, you can use this tool to assemble your fasteners. There's an easy-to-use interface that allows the user to define the position of the fixing, if you will, by selecting either a datum point, a datum axis, or a free point. After selecting the location, then we need to select the plane to locate the screw head, followed by selecting the plane to locate the nut head or the end of the threaded hole. Once we've done that, we need to define the desired fixing, basically selecting the type of fastener that you want to use and any types of holes that need to be created, including counterbores or countersinks and so on. This is a comprehensive out-of-the-box library that's available with the tool, and there are some expansion abilities as well. So once you have decided on the placement and the hardware configuration, the Intelligent Fastener extension will automatically calculate the fastener length. It will create the required holes at the part level if needed. No assembly references are created, and this is a part level feature, not an assembly level feature. Then assembles the fastening hardware, and then also prompts you if the references are to be patterned. So if you assemble these fasteners on, say, an axis that is patterned itself, it will then prompt you if you want to reference pattern these items. After the design changes, the Intelligent Fastener extension provides tools to check whether fasteners are long enough, as well as check whether or not the holes are aligned with the fasteners. Now, some of these functionalities are available in different versions of the tool. There are two versions. There's a light version and a full version. And as you can see from this diagram, that there are some limitations with the light version, but with the full version, you get some expanded options as well as the ability to customize the library. We also have some placement limitations with the light version versus the full version, as far as automatic hole creation, counterbores, length selection, diameter selection, patterning, and so on. So in summary, this is an improved standardization, a comprehensive library of fasteners which are fully customizable with the full extension, improved user productivity, 90% quicker, 68% less mouse clicks, and if any fasteners have been deleted, will automatically delete the holes that were created. There's an improved design workflow, the automatic creation of holes without assembly references, and a removed requirement to manually align fastener holes. There's also improved design accuracy. There's verification tools to check that the fixings are long enough and that the holes are fully aligned. Next thing I want to talk about is some improvements to the assembly around simplified representations. Oops, excuse me, I think I went to the wrong slide. So as far as the user interface improvements, we now have the ability to automate the window activation, so no longer we need to manually activate the windows when switching from one window to the next. There are some improvements to the right mouse button command menu. Okay, this has been modernized to include icons now rather than just text indicators. This is also customizable through the options dialog if you want to add or remove commands from the right side mouse button. There's an option now to turn off the version extension when you save the files, so you no longer have to save the version iteration. You can overwrite the existing iteration. Of course, any existing revised parts will remain in the file system. This makes your product more Windows compliant, improves the productivity, and also have the right commands available in your right side mouse button. As far as part modeling, there are some user improvements around the removal of feature operations, reorder, read-only, a new spinal bend interface. There's some reference control enhancements, overhaul the ability to edit and replace references. Also displaying missing references when trying to edit the definition of failed features. There are enhanced capabilities with collapse, the increased maximum draft angle, the ability to reference pattern now from any pattern number, and there's also the enhancements to the geometry pattern. There's some new capabilities in the surface untrim and a new chordal round, some additional surfacing tools, some boundary blend enhancements, flattened quilt enhancements, and then some additional analysis tools around connections with surfaces, evaluating minimum thicknesses, some draft analysis, some reflection analysis improvements, as well as some knot analysis. So first of all, there's been a lot of removal of the menu manager, and this continues through the evolution of Creo. They're trying to get rid of as many of those, pop-out menu manager options as possible. So in this version, we've addressed the feature copy, a reorder, and insert mode. And to show you these, here's a quick demonstration. So in this case, the ability to drag and drop has been in the tool for a while. We have a new reorder dialog for reordering features. And then we also have some capabilities with the read-only features. This has a new user interface, and they're now grouped in the model tree with an icon that represents a lock to the left of the feature. So in this case, when we set features as read-only, we can use the default to specify all features. You notice if we try to edit the dimensions of a feature, that we get an error that says that that feature is read-only and cannot be modified. And then if we select a feature from the tree and set that as the last read-only, every feature before that feature that has been selected becomes a read-only. The benefits are with this that we're continuing to remove the menu manager options and also improving the user experience and productivity. There's a new user interface for the spinal bend tool. This again is continuing to remove the menu manager, but we have options to now bend the entire object to a blind distance or to a reference. We have options to maintain the length and keep geometry outside the bend area, and easier to control the cross-section property without relations. So with this example, we're selecting the curve for the spinal bend, and then selecting the geometry that we want to bend around the spine. And then we have options to specify the depth or the length of the bend. So we have a blind depth, we have a to selected depth, and we also have options to lock the length during these depth manipulations. And then we also have the option to remove any geometry that is unbent via the depth manipulation. Next thing I want to show you is some new capabilities with the edit reference user interface. We now have the ability to reroute other features with the same references, option to step through multiple solutions, and replace a reference used in any or all features. So in this example, we have several features that we will edit the references for. First being this boss on the left-hand side. And you'll notice with the edit reference dialog, we can scroll through the references to highlight them on the model. We can use the roll to option to roll the model back to a selected feature, and then highlight the references and select any new references that we want to choose. In this case, you'll notice that we have some failed features. So if we edit the references for those failed features, we can actually see them now in the Edit References dialog and select the appropriate reference to replace. So next example, we'll move this hole from one surface to another using Edit References. We'll select a new face for the hole to enter and a new horizontal or linear dimension reference. And in this case, you'll notice that we have the option to handle the children just by selecting them from the tree to move any children or child features as well. In this example, we're moving a feature that has many children. And we can select which children we want to move with the feature. And as you can see, it's very easy to reroute feature references with the new user interface. Next, the ability to show missing references. So this will allow you, through the redefinition of features that have been failed, to actually see the last successful regenerated reference of that feature. So in this example, we're going to edit the definition of this extrusion, removing the sketch geometry, and then recreating it with some new geometry. Add some dimensions to the cross-section, deleting any conflicts. You'll notice that many of the features in this model have failed. So as we go to select these features to seek information or edit the definition, we can determine any missing references and have them displayed on the screen. So although that axis was removed with the definition of the feature, we can still see it in the model. And so now we know which axis needs to be replaced, and then select the new axis. And then continue through the editing definition of these features. In this case, we see the rounds reference is missing. It's highlighted on the screen. We just need to select an appropriate reference to replace that. And then again, the pattern fails. In this case, it's an axis pattern, so we need to select a new axis. And of course, the feature, of course, is going to fail as well, and we would need to replace the references for that rib feature. So of course the benefits here are it's a faster, more powerful and intuitive reroute interface. There's a similar user interface for the edit and replace references, and the ability to easily identify any missing references. We also have, through the user-defined feature placement, now an automatically advance to the next reference required, and then the same is true with the paste special. Now, rather than having to select from the list, there is an auto advance option. Some enhancements to patterning. One of the really nice things is that we can now reference a pattern from any pattern member. If you add features to a pattern, we no longer have to add them to the leader feature or the first instance in the pattern. We can add them to any of the pattern members. So in this case, we're going to highlight a pattern. We can see where the leader feature is as well as where the subsequent instances are. And if we select to create a whole, and we'll select any one of those instances of the pattern and have the ability to reference pattern that feature. In previous versions, that was only had the ability in an assembly reference pattern, but now we have that as far as the part modeling feature patterns. And here we're adding a round to a different instance again, and reference patterning that round to all of the instances of the pattern. We also have some enhancements to the geometry pattern. We can now handle the topology changes using attach options, and we also have the option to pattern only the quilts of the solid geometry using the copy option. In this case, we have a small boss on the inside of this model. We'll go ahead and create a geometry pattern with this using the axis option. In this case, using the copy functionality, we have the surface quilts that are patterned. Of course, we can edit the definition of this pattern and change that option to actually create the attachment, and we see what the difference is in that example. Benefits here are an improved usability, more flexibility with reference pattern workflows, and more flexible and robust geometry patterns. There's an enhanced collapsed feature. We now have the ability to collapse features into either independent or incremental geometry, but also have the ability to keep any analysis, annotation, published geometry, or cosmetic features and reorder them in the tree. We also have the increase in the max draft angle to 89.9 degrees. We have some new surfacing tools. We have an ability now to untrim a surface or a quilt. So if you have surfaces that have been imported, we can then take those surfaces and, through the copy and paste functionality, untrim them and then keep their full associativity to the original surfaces. So in this case, we have an imported feature, which is built up of several surfaces. We can select one surface and, using the copy-paste functionality, copy that surface and then use options to untrim it using either the envelope or the domain. And there's the resulting copy with the untrimmed functionality. We can also do that with the entire imported feature if we need to. So if we take that feature and copy and paste that, and now we can untrim all of those surfaces hiding the original surface and the resulting surface copy. There's a new chordal round functionality for surfaces. This provides options for a conic surface or curvature continuous surfaces with shape controls. Also supports the rolling ball and normal to spine options. This is a really handy new round option. The chordal round basically keeps the continuous round width, or if you will, the continuous chord measurement of the round profile. So we can see if we create just a typical round on that edge, that the round tapers on the ends through the tangency of the surfaces. If we change that to a chordal round now, we maintain the round's width through the entire round. We'll do this again. Another edge. Again, you see how that round kind of tapers off near the end as the surfaces become more tangent. In this case, we apply the chordal round option and the resulting difference. We change it to curvature continuous. We have the options to edit the tangency. And this makes for a really clean surface transition. If we look at this with a reflective analysis, we can see how nicely that round gets created. Benefits here are, it's more easy to understand and change the imported surfaces, and the ability to build more attractive geometry with the chordal round. There's some enhancements to some of the surfacing tools. There's improvements to the boundary blend option, the quality of the surfaces, the degree of the surface that we can create. We have abilities to optimize the shape, improve the connections, as well as improve the internal continuity. We also have enhancements to the flatten quilt tool. We can now flatten non-rectangular surfaces, quilts, and solid geometry with symmetry support. In this example, we'll take this surface model and flatten it about a coordinate system. And there we have the resulting flattened surface model. Benefits for this, we're having improved surface quality and connection, also improved productivity. We have some new analysis tools for analyzing the connection of surfaces. We have the ability to evaluate geometric connections, surface to surface, two-sided edges, all edges, curve to curve. We have the ability to analyze for position, tangency, and curvature. The information that can be displayed is the min and maximum deviation, color areas outside of tolerance, and the option to show the porcupine curve. We also have control over which tolerance to check against. The benefits here are the ability to validate curve and surface connections. There's improvements to the draft analysis tool. We can align the result display with the display style. We can also use lighting to support the better understanding of the depth, and also support for less than 3 or 4 colors. We also have a new 3D thickness checks. This performs a wall thickness for plastic and cast parts analysis. This also supports both part and surface models with the minimum thickness being displayed. We also have a knot analysis tool now that allows us to display knots and or the control mesh for B-spline surfaces and curves. So this will provide for better analysis of your surfaces. And also we have the ability now doing a reflection analysis to control whether or not to use the actual color of the model. Benefits here are the identify design flaws and eliminate late-stage rework of production tooling, and reduce the time to analyze wall thicknesses of complicated parts and improve the accuracy for identifying potential design issues. With sheet metal, we have some new enhancements with the form functionalities. There's a new user interface and workflow for using die forms. There's also some new abilities with the flattened geometry for attached to forms. Some bend enhancements, bending multiple planes, bend line relief placement, and creating multiple bend reliefs. And some rip enhancements to be able to create risks between different contours on the same surface. So with the form improvements, we have a new user interface for the workflows for the die form. This is similar to a punch form. There are several examples that ship with the product. The pocket is automatically found and easily changed with the tool. We can also predefine it in the reference model. And we use annotation elements to predefine the pocket and excluded areas. So in this example, we're going to place a die form on the model. We have the choice to make it dependent or independent of the die that's saved on the system. We have options to vary the die model if we choose to make it independent. And we have choices to place the die using coordinate system or using placement references. As you can see, using the coordinate system is a much quicker method of placing these types of dies, forms, and also the ability to quickly pattern them as a reference pattern. And this is showing the component interface that has been defined with that die form, which makes it easily placeable on the sheet metal model. We also have new abilities to flatten geometry attached to forms. Flatten form now supports unbent geometry. Flat pattern unbends walls on forms first. This example, we have some forms and some additional wall features. We're just going to back up through the model to show how this model was put together. And then show the abilities to flatten these forms. So we can use the flatten form either before or after an unbend operation. We can also flatten the pattern, and we have options to select how to handle the form geometry. And benefits here are improved productivity and the user experience, as well as increased in design flexibility. We have additional tool improvements for bending sheet metal parts on multiple planes. We can apply bends to multiple coplanar surface. This is really neat new functionality. In this example, we have several surfaces that we're highlighting on the model. We're going to bend those surfaces in a single bend using a bend line that is predefined, and then determine which direction to create that bend. We'll create a new bend. This is an offset bend. Selecting an edge off the model, defining where to place the bend. And then as you notice, when we drag the relief out, that the bend will follow through the entire model. And again, we need to flip the bend to determine which direction to create the feature. We also have new bend line relief placement. Relief cuts normal to the end of a bend line up to the bending plane boundary, and no relief extends bend to bending plane boundary. In this case, bending from an edge. We have options to create that bend boundary and bend relief. And then adding a ore ground bend relief. Okay, and then also have the ability to create multiple bend reliefs as appropriate, not just at the bend line ends. Improvements here to productivity and user experience, as well as the increased design flexibility. And then finally, we have the ability to, improvements to the RIP options. We can create the sketched RIP or RIP connect on different contours on the same surface. This first example, we'll just create a RIP. It's going to be a RIP connect, and select the references to define the RIP. And then now we can bend that tab, creating a bend line, of course. And the improvements are here for the increased design flexibility. So with the flexible modeling environment, we have some really nice enhancements around the handling of rounds and chamfers, support for non-circular rounds, the ability to now handle chamfers and edit them, and also improvements to the round chamfer recognition. We have some enhancements to the patterning, a new flex pattern tool. We can propagate the pattern from any instance of the original pattern, and we can also propagate the user-defined bounding edges. We also have some improvements to the flexible features around the tangency propagation, a new pool option, and support for an inferred axis when changing cylinders by dimension. So first of all, support for non-circular rounds. We can use either symmetric or asymmetric conics and curvature continuous rounds. Removed and recreated in the flexible modeling tools as we make these changes. And we can edit the round from a circular to a conic to a curvature continuous to a two-dimension conic or a two-dimension curvature continuous. So some examples here. Using the flexible modeling environment to recognize the round, we have choices to remove the round or change it from a conic to a circular. And as we move these surfaces and features, the rounds are basically deleted and recreated on the fly. So new examples on performing move operations. We also have now the ability to handle chamfers and edit them. Again, these are removed and recreated during the operations. We have all the chamfer options that we have in the traditional modeling sense. Two-dimensional, angle, 45-degree by dimension, and so on. And we have the round chamfer recognition feature, which allows us to control how the system treats individual round-like and chamfer geometry. So in this example, we're going to move the face of the model, and you'll notice that the chamfer is trying to be recreated during the move operation. And now we have the ability to identify that geometry as a chamfer and move the chamfer with the movement of that face. So we just recognize that geometry as a chamfer. And now when we take that face and move it, that chamfer will move with the face. And because we've told it it's a chamfer, we can now edit the chamfer to change its attributes, either removing it altogether or changing the dimension scheme. So the benefits here are we have the ability to preserve engineering intent of non-circular rounds and chamfer, and certainly more flexible and predictable geometry handling. We have a new flexible pattern tool. This allows us to pattern geometry with flexible support. Rounds and chamfers, again, are removed and recreated, and the pattern instances are attached and merged to the solid. In this example, we have a small boss on the internal of this model. Create a pattern, an axis pattern. You notice how well that this tool handles the attachments. Of course, we have full control over how we choose to attach these features to the model. Of course, if we don't attach them at all, they become surface quilts. And various options for controlling the attachment again of the pattern. So some very, very powerful patterning tools. We also have, just like in the traditional modeling sense, we have the ability to pattern propagation from any instance of the pattern. This makes changes very easy. We also have the ability to propagate the defining bounding edges if needed. So in this example, we're first going to identify this boss and recognize the pattern. Now that we've recognized this as a pattern, if we add any geometry to the instances or make any changes to those instances of the pattern, we can then propagate those changes to the other pattern members. Benefits here are we can pattern geometry regardless of the topology change or the presence of rounds or chamfers, and certainly provides for a more flexible modeling workflow. Also have some enhancements to the tangency propagation within the flexible modeling environment. We can maintain tangent connections from modified geometry to the adjacent geometry, and we can also apply conditions while moving the geometry, either fixed axis, propagate through, etc., to control how the model is adjusted. In this case, we have some features that we're going to offset. In this case, we'll apply some tangency constraints. Of course, without applying the tangency constraints, the side surfaces are created through that pool geometry. Assigning default conditions. Notice the difference in the change between those two options. In this case, we're going to create a fixed reference. And then also fix the tangency if needed on any surface. We have a pool option now that allows us to attach move geometry by creating side surface along the boundary of the move geometry, or by extending the neighboring surface. If you can see in the examples in the lower right, the difference between move and pool. Move just takes the surface and moves it accordingly, whereas pool will create any side surfaces as needed. Benefits here are the ability to create and modify more complex geometry with improved workflow and more predictable results. Inferred references for move by dimension. We have now the ability to select an axis when using a cylinder to move. Some sweep enhancements. In the surface design extension, the interactive surface design extension, ISDX for style surface, we can create a curve from isoline, and then there are some general enhancements to the feature preview, options to merge on exit, and options to show trim surfaces. We also can import curves now from the Creo Sketch tool. So with the sweep enhancements, we have support for high degree curves. The degree of surface will be defined by the degree of curves. Support for constraints. Boundary edges now can have connections applied, normal, tangent, curvature, draft. And support for the sweep when the profile does not touch the trajectory. For example, sweeping a circle along a curve for planar profiles only. So in this example, we're trimming some surfaces. Selecting the tangency option. Creating another surface. Surface trim. Using the edges to define the trim. And also specifying the tangency condition. Creating a boundary surface with the cross curve selection and specifying the tangency condition. Displaying the knots on the curve to help analyze the curvature. And then creating a surface sweep along a curve. Benefits here are we can build smoother surfaces and connections. We have control over the connection type, and more intuitive, less steps to build the geometry. We have now ability to create a curve from an iso line. This is a new option for curve from surface. The ability to create the curve defined on the surface as an iso line. and remains an isoline curve and updates, but can also be converted to a curve on surface or a free curve. So in this case, you'll notice a new icon under the curve tool, and we just select the surface and determine which way to create the curve. And that curve has the ability to be edited as far as its dimension value along the surface. Again, some benefits here are the ability to build smoother surfaces and connections and have a more predictable change to the shape when making changes. We have some general enhancements, some capabilities. The new geometry preview by default is to be solid shaded rather than a transparency shade. We have an option now to merge the surfaces upon the completion of the style surface or style feature. And we have now a change to the show trim surfaces default. So by default, the old preview was to not show the trim surface. The new default is to show it. Of course, these are all settings that can be applied through your configuration. This provides for more consistency with the attached preview behavior, easier to visualize the geometry, and greater control over the surface intersections. We also now have the ability to take curves that were created from the Creo sketch tool. We bring those curves or those sketches into the model. We can automatically use those curves to create a style feature. Any manipulations and scales applied inside the images would also be applied to the curves during the import. And then we have control over the visibility at the assembly level. So some enhancements to the Freestyle tool, or Freestyle feature I should say. We have the ability to join the mesh elements, align external geometry, and manipulate the performance of dragging the surfaces. In this first example, the new join command allows us to join faces and edges. It supports the mirror functionality. It's dependent on the order of selection, meaning that the second selected entity moves to the first, and is available using the right side mouse button. So in this example, we have a freestyle surface. We're able to remove some faces off that surface and then drag the edges out, and then connect those edges back again to the model, and then closing any voids that are created as a result. Do a little undo here, back up to where we were to begin with, and we'll take this face and we'll drag it off of the model. Of course, that leaves a gap that we want to close, so we'll select these two faces and use the merge option to connect them and the resulting geometry. Of course, there's several ways to achieve the same result. In some examples, if we have an open face, we would use the edges rather than the faces to connect the geometry. So if we first remove these faces, connect them, that's the result. Or if we remove the faces and connect the edges, we have a similar result. Some benefits here are the increased speed for changing control mesh topology, very easily connecting or removing faces from the model, connecting edges, and so on. We have some new alignment functionality to align now our Freestyle surfaces to existing or external geometry. This provides you some level of parametric control over those Freestyle surfaces. We can connect either by position, through normal or tangent operations. We have control over alignment limit handles and support for one and two-sided edges with or without creases. Of course, any curves that we're using to align to must have some level of curvature to them. They can't be straight lines. They have to have some level of curvature. This is a really neat example where we're creating this lower bracket on this bicycle frame. And of course, the tubes of the frame are created perhaps through an extrude option for functionality. But now here we have this Freestyle feature that we're going to use to connect all the tubes together at the bottom bracket. So we create a primitive, make some adjustments to the primitive, kind of pre-position it before the operation. We'll select some faces to be removed, and then align those seed surfaces from those faces to the external geometry and have the ability to control the tangency condition. Of course, they've sped this video up a little bit to be considerate of the time. Of course, these connections will update through any changes to the external geometry. So if we take this frame and make some adjustments to it, you'll notice that that Freestyle feature now updates based on changes to the external geometry. So some of the benefits here are adding the parametric ability to capture design intent for Freestyle geometry, as well as improvements to productivity. When it comes to manipulating the geometry in Freestyle, we now have the ability to control the manipulation of the mesh. So basically improving the performance when dragging geometry. So we uncheck the drag performance improvement. It takes just a little bit longer to make the drag. It's a higher quality through the drag operation, but again, takes longer to perform the operation. Some graphics improvements through the rendering tools. We have now support for high dynamic range, realistic bump maps, realistic materials, and ambient inclusion, improved active component display, order independent transparencies, and now the ability to reorient our models normal to a selected reference or face of the model. With the rendering abilities, they've come a long ways now with the rendering tools within Creo Parametric. We have support for realistic materials, metal, glass, plastics, etc. Closely matched to the advanced rendering extension results. We have the high dynamic range support in shade with reflections, the ability to control the reflections for the lighting in the background and control the intensity, saturation, rotation, zoom, and height. We have realistic bump mapping, so if you have textures within your surfaces, we can now show those in the rendered environment. And also the ability to occlude the ambient lighting. With this example, we have a coffee machine that we're going to take into the rendering environment. We'll add some materials to some of these components. Select another material such as black chrome. This is sped up considerably, but you can see how easy the workflow is to create these renderings. Adding some wood grain to this handle on the coffee machine. Adding some texture or bumps with the degree of the bumps, the height, and so on. And then placing the coffee machine in some scene. So very, very comparable to what you would get in the advanced rendering environment. So the benefit here is it allows our designers now to work in a more immersive environment when creating renderings. There's some more improvements to graphics around realism performance, improved active component display, the ability to reorient normal to the face of a model, and the order-independent transparency. This is something that I think users have been wanting for a while, is the ability to reorient the model based on a selected planar reference, if you will. So if I select any plane off the model, I can reorient normal to the view. If I use an edge or a cylinder or a datum axis, those then become normal to the screen. So we can very quickly reorient the model as needed, especially working in some complicated geometry situations where everything's not necessarily orthogonal. We can reorient the view very quickly. So improved usability in our assemblies and improved productivity for orienting the model. Very quickly, I know we're running out of time here, but I have some few enhancements to the assembly environment. First is the design exploration extension, the update controllabilities, some advanced assembly improvements, and some general enhancements. First of all, this new design exploration extension allows you to change the model and take it down a different path, basically, to evaluate new designs or just for playing around with any ideas for changing your models or assemblies. So this is done in a Pro-E session, but is also compatible with PDM Link or any PDM tool for that matter. So the capabilities that we can initiate changes with already modified items in our workspace. We have a one-way download when in an active design exploration session. We can download the data into the session, and then this data gets stored in what's called a TMZ file. So in this example, we would take an iteration from a PDM object, bring it into a Creo session, open up the design exploration session. Even if the model was already modified, we can create a checkpoint and then create several different design paths, if you will, and establish checkpoints along those paths. So we can create several different iterations of this model or assembly. If we decide which one we want to keep, we can upload that back into our parametric session and then also check it into our PDM system. Of course, this is all managed through this TMZ file extension, which allows you to document the changes or the iterations, use the data for a design review, or to go back and revisit the decisions that you made through the design iterations. This allows you to streamline, simplify design changes, provide for an interactive design review, and keep track of the decisions that you've made. In this example, we're really using this tool kind of like a design sandbox, if you will. We can create snapshots for the entire session content, capture the incremental changes, toggle the checkpoints, split into different directions, and accept the changes and revert to original starting point. So this example is speeded up considerably, just to show you the functionality, creating a design exploration session. Notice that this model is indicated as already been modified. Modifying some additional dimensions, adding some new features, assembling some new components, creating a checkpoint, making some additional changes, creating another checkpoint, continue making changes, and continue saving checkpoints. And then we can go back and review any of those checkpoints that we had created. Then finally accepting the current state and saving the exploration session. So some benefits here are certainly better control over evolving complex designs, more predictability of changes, impacts, and less errors in iterations. We have new abilities to integrate the layout tool into our three-dimensional models. We have some new data sharing features, a built-in update control for the layout feature and its children from a single access point, and direct creation of most popular 3D features, extrude, revolve, sketch, using the layout geometry. Benefits for this are the streamlined associative process for iterative conceptual design and evolving 2D and 3D content. We have new abilities for reference control. This option adds an ad hoc external referencing management capability to actually remove the dependency of these external references. So this is very handy if you're working in a collaborative or assembly environment, and as you're selecting assembly references, you do not want to establish those external references, if you will. So this allows us to create models using assembly geometry that are fully independent of the assembly. It's a safer way to work in the assembly without the risk of unwanted dependencies. There's a new notification center which shows us a comprehensive status trail in the model tree for any failures of the model. We have live indications of issues that require our attention. And we have a notification center dialog that allows us to quickly see anything that needs to be addressed. And then we also have the ability to customize the notifications that are used in that notification center. It's an easier way to identify, locate, and fix design issues, as well as monitoring design changes and potential problems before they become an issue. And then finally, the multi-CAD abilities with Creo Parametric 3, as well as being able to import neutral file formats that we've been able to, in the past, bring them directly into Creo Parametric. We can now import CATIA, SolidWorks, Siemens, NX files, and so on without requiring a separate translator. With the addition of some collaboration extensions, you can also use non-native Creo models in your assemblies. What this allows you to do is work with a number of standard file formats, including STEP, IGES, DXF, and so on. With the use of Unite technology, convert data from other CAD systems, incorporate non-PTC Creo data directly into designs without creating additional objects or files to manage, and support the export of non-PTC Creo formats. Now, I don't have any examples of this, but what this allows you to do is actually take a model from another software tool, such as a SolidWorks model, assemble that model directly into a Creo assembly without converting it, and keeping its ties to its native format. What that means, if somebody were to open up that SolidWorks model in SolidWorks and make a change, we would see those changes updated in the assembly context automatically without the need to reconvert. Of course, this requires additional collaboration extensions, but it's very neat functionality, the ability to use those models directly in a Creo assembly. And with that, I'd like to open up the floor for questions.
All right, Sean, so we've got a couple of questions here. The first would be, let's see, if sending assembly models with intelligent fasteners to client without the extension, will the model fail?
No, because those models are assembled directly into the assembly. So once it's used, it becomes, internal to the assembly.
Okay, next question would be, is missing reference control available for assemblies?
Yes.
Okay, I think that's all that we've got, actually. If you all have any more questions, please feel free to reach out to your TriStar representatives. Thank you, Sean. We ran a little bit late, but obviously there's a lot to cover with this new product. So, like I said before, feel free to reach out to any TriStar representatives to get your questions answered. Just a reminder that this webinar was recorded and will be posted on TriStar.com in the Resource Center. You can find that by going to TriStar.com, find the Resource Center at the top right, and we have a listing of all of our most recent webinars. There will be 4 more of these webinars covering Creo 3 in the next 4 weeks. You can find these webinars and others by visiting TriStar.com/events. And with that, thank you, Sean, again, and thank you all for attending, and have a great day.
Thank you, everybody.